Hey there guys, and welcome to the video. In this session I want to discuss how you can use the equality operator on a custom class of your own design. So the equality operator, say, just do a quick example at the top here. If I say 10 is equal to 10, let's see what I get. I get true, and that's absolutely fine. If I do 10, the integer, is equal to the 10 as a float, yeah, cool, no problem at all, that's fine. Let's go ahead and do 10 as a string. And then we get false in this case, and that's absolutely fine. So we can see with the built-in types, Python is able to use this equality operator to basically say, is this equal to this here? And that's down to, if I can quickly show this using dir. If I do dir of integer, so I'm asking what attributes and methods does the integer class have? And we can see one of them, if I can find it, is this guy here. There's EQ. There's also NE as well, which is lurking down here somewhere. And that's is equal, is not equal. So whenever you go ahead and use this equality operator here, what you're actually doing is going to the class and evoking the methods such as this, or if you're going to go ahead and use this one, you're actually evoking not equal to, like this here. So with our custom class, we actually have the chance to write this in our own class and basically choose how our instances should behave when someone does, in this case, is John equal to Alice? So let's go ahead and quickly clear the screen here and write what this does. So I've got a basic class. This class takes in a name and an age, and my two instances here are John, Alice, and they have John 25, Alice 25 as their respective attributes. So the first thing I want to do is just build my basic EQ method. So let's make a bit of space. I'll bring this down here ever so slightly. And if I just do def dunder EQ, some people call these dunder methods, magic methods, special methods. I call them dunders for the double underscore, but that's absolutely fine. And of course, like any regular instance method, we're going to take self as the first argument. The second argument is what we're comparing our thing to. So if we did is John equal to something, that something is this here. So we can just say other in this case. So the next thing we want to do is say, what are we going to compare? So in this case, let's compare ages. So I'm going to write a quick doc string and just say, check the ages are the same. Okay, there we go. And then I'm going to say return self.age is equal to other.age, like this. So effectively, if we were to do is John equal to Alice, John is going to be self, other is going to be Alice. So we're basically saying, is John's age equal to Alice's age? So if we now come down here and do John equal to Alice, and if we hit run, we should see true, because John and Alice both have the same age. Let's make Alice a year older, and therefore we now have false here. So that's a really simple example. All we're saying is when the is equal to operator is called on an instance, use the ages as the metric for comparing those. It doesn't have to be. You could do name. I'll leave the doc string for just a second. This is false, but of course, let's suppose a name change happens for whatever reason. There we go, they're now both true. So you can use whatever you want. You can use any particular element of your class, and that's absolutely fine. The issues tend to arise when you try to do things like this here. And you can probably see why. So imagine what's happening. This 10 is being passed to other, and we're doing other.age. So you can almost smell this error message brewing before we even write it. Yeah, the int object has no attribute of age. Of course it doesn't, because we're basically defining in our class that the thing we're comparing John to, or Alice to, we're saying look at the age attribute of that item. So what we can do to avoid this error is apply some sort of checking in here. So a really nice way of doing it is to do try. And in this case here, I'm just going to do a blanket accept. A blanket accept normally isn't the greatest idea. However, let's just do return false like this instead. Let's just hit run, check we've got no syntax errors. So now if I do John is equal to 10 here, and we get false. So rather than getting the error this time, if I blank this off for a second, just bring the error back. Yeah, and there we go. Int object has no attribute age here. So we can actually catch that instead. Bring this all forward. So we're saying, if for whatever reason the is equal to is called, and the other item we're checking we're equal to, in this case 10, if that doesn't have the age attribute, we can go ahead and return false. What you might want to do is do attribute error, in this case here, just to catch that specific error. What you could do, we'll take it a step further, we could do the following. We could do, rather than just returning false, we could do if is instance. So say, if that other object happens to be an int or a float, return self.age is equal to other. And let's hit run, and we get false here. Let's do John is equal to 26. Get false. That'll be because John's 25, not 26. Let's try that again, shall we? And we get true. So one more time, we're saying when is equal is called on, let's try Alice first. So in this case, we've said John goes in as self, Alice goes in as other. So that's John, that's Alice. And try and compare John's age to Alice's age. And just return if they are equal or not. In this case, yeah, true. They're both equal, they're both 26. However, if we do, in this, let's say in this case, the second operand, in this case 10, this 10 does not have the attribute of age, therefore it's going to raise this. Check to see if that thing is an integer or a float, and if it is, just go ahead and return self.age is equal to other. What you might want to do is to try and catch, say that was a string or something like that. Let's just do return false here. So let's do John 10, and let's do John 10 here, just to try and catch those eventualities. There we go, true, false, false. Let's make this one 26. True, true, false. And there we have it. So that's how to implement EQ in your own classes. Cheers for watching, guys, and have a great week.